Okay, 53. I rewrote it as a quotient because I think a quotient rule is easier to simplify, but you didn't have to. So, first derivative, low, d high, minus high, d low, draw the line and square below. Factor in the numerator, factor out an x and an e to the x. And you're left with 2 minus x. Cancel one of the e to the x's. So my first derivative right now, would be x, 2 minus x, and e to the x. Set the numerator and denominator equal to 0. Numerator equals 0 when x is 0 and 2. Denominator equals 0. Never. E is always positive. Okay? So now, plugging those two into the second derivative would be using a second derivative test. Again, I'm not going to do that because a first derivative test is just way easier for this problem because I don't feel like doing the second derivative of that. So I'm going to use a first derivative sign chart instead, even though they told me not to. Okay, the denominator is always positive. Don't need to worry about that. The numerator, if I plug in a 1, I get positive, positive. If I plug in a negative 1, I get negative, positive. If I plug in a 3, I get a negative. So therefore, this guy is a min and this guy is a max. So min at x equals 0, max at 2. And again, that is not a second derivative test. I just did the first derivative test because I did not feel like doing the second derivative of that problem. Hopefully you could do the second derivative test for the rest of them, other than, I guess, was it 49 and 53? Both of those I would say, nope, I'm going to stick to the first derivative test.